Hello class, welcome to Unit 3.2A, Relations, Domain, and Range. Okay, first thing we're going to talk about is relations. Now, relations, by definition, is just a set of ordered pairs. So your ordered pairs are just like any x, y coordinate, and you're just going to have multiple different cases. So as you can see down below, there are 4 different ways we're going to order these ordered pairs, or kind of group them, which would be just by ordered pairs, by table, by mapping, and by a graph. And before we get to that, let's talk about the set of x values. This is called your domain, and the set of y values is going to be called your range. So when we look at x values and y values, that's going to be an important thing that we are looking for. So when you look at your ordered pairs, we'll take these numbers, group them by ordered pairs. What our domain is looking for is all x values. So if you look at -3, now the one thing you do with these is we're going to be looking to try to get them from least to greatest. So when we are looking at our x values, it looks like we got 2 -3s, but we only have to write it once. Then we're going to look for -2, +1, and 3. Now when you look at your range, remember what the definition of range is. Your range is looking for your y values. So again, looking at -4, looking at 0, looking at 1, 2, and 5. So that's your domain and range. If we look at these, the other way we can take these same ordered pairs and kind of put them into our table. Now, again, a lot of times with these, we're going to try to put them in numerical order, least to greatest. But the important part here is your x and y's match up. So if we got -3 and 1, I'm going to jump down there to the -3, 5, just to try to get our x's in order as best we can. We got -2, and its pair was 0. We have 1 and 2, and then we have that 3 and -4. Now, once again, if we are trying to use this to find our domain, well, what's our domain values? That would be all of those x values. What was our range values? Range is going to be all of those y values. Okay, so if we take a look at mapping, the way mapping works, if you're creating these yourself, a lot of times we, again, are trying to go from least to greatest as we go. And -3, obviously written twice, we're only going to have to draw that once. But we got -3, -2, a 1, and a 3. And then over here on this side, it looks like we had the -4, 0, 1, 2, and 5. But again, it's going to be important here when we match these up. We had a -3 paired with a 1. We had a -3, right? -3, 1, -3. Also coming off that same value, basically telling us that that one x value over here has 2 y values. As we look through, we had -2 going to 0. We had 1 going across here to 2, and then we had 3 drawn up here to -4. So sometimes we'll get a lot of crisscrossing going on, but just remember, wherever those arrows are drawn, that's kind of telling us that, oh, we got -3, that also is paired with a 1 and 5, -2 is paired with 0. And of course, the last set here, just to kind of go through and graph, remember, these are your typical coordinate planes, and just kind of working through. We got -3, 1. If we want -2, 0. We want +1, 2, 3, -4, and -3, 5. Just going to be up here. So all of these, no matter which ones we're looking at, are going to end up yielding those same domain and range. It's just a matter of how we find them. If we find them in the map, we're looking for domain x values, range is our y values. But on the graph, then we, again, just got to kind of convert them back to an ordered pair in order to solve. Okay, let's take a look at a few more examples to elaborate on. Okay, take a minute to practice numbers 2 and 3, finding your domain and range, and then also just converting those ordered pairs into our tables, our mapping, and our graphs. All right, good luck. Take maybe pause your work here before we move on and check. Okay, now that you're done with your work, take a minute to pause and check your answers. Okay, so we just got done hitting the domain and range of just some ordered pairs when it's basically just kind of matched up as points. Now what we're going to look at is the domain and range of continuous graphs. So when we look at these graphs in 1 and 2, for the domain, because we know that this is your x values, what we're going to want to be looking for is basically scanning our pencil from left to right and identifying which x values in which you're touching the graph. And for the range, since we know they're your y values, this is going to have us looking up and down, and this will help us identify the y values in which you're touching on the graph. So let's take a look at these two. Well, I guess before that, let's take a look over here and say, well, domain and range of these types of graphs are usually written using inequalities or interval notations. We're going to kind of focus on writing inequalities right now, not so much the interval notation. So for your domain values, we're going to have things like x is less than, x is greater than. Maybe we have x is less than or equal to, x is greater than or equal to. And then when we talk about range, since range is talking about y values, we'll have things like either y is less than, y is greater than, or we might have y is less than or equal to, y is greater than or equal to. So let's take a look at domain. We may also have instances where your x's could be all real numbers and your y is all real numbers. So let's take a look at what we're looking here. If we take our x value, okay, so now we're just basically looking left to right. Okay, right now, left to right, that is basically telling us that we can go forever, those arrows, in both directions. So that is going to cover every x value. So we can just say that our domain is x is equal to all real numbers. Now, if we look at our range is only talking about y values. So y values is looking up and down. Well, if we're going up, that means we are taking everything going up. Well, what's that lowest value? This is going to tell us here that y has to be greater than or equal to, well, the lowest point on that graph was -2. All right, because obviously down here, there is no y values, but anywhere on your graph, we'd have like -1, 0, 1, 2, going all the way up, basically to infinity. So anything greater than -2 would be our domain there. Okay, when we look over here at this circle, we might have to write our inequalities a little bit differently. But if we are looking at our domain, which is our x values, looks like it starts over here. And if we kind of trace our graph, it covers every value between those. Now let's go back and look at a number here. So -3, and it looks like it goes to a +3. Now remember, domain again is focusing on x's only. And down here it would be the same thing. So basically we have every number between -3 and 3 covered. Well, how do we write an inequality there? This is going to be one of those compound ones where we could say, well, -3, we know x is greater than -3, but when we go greater than, it also has a stopping point, so it has to stay less than or equal to 3. Sometimes we have different instances of those. And if you look at your range, which is your y value, so now we're looking up and down, well, where's our highest point? That looks like up here, which also is a 3. And this one down here, which looks like it's going to be a -3. And we're tracing all the way down, tracing up and down. So basically we have, in a similar fashion, everything between 3 and negative 3. So starting with negative 3, we know that y is greater than or equal to negative 3, but it's also going to be less than or equal to 3. So these ranges, domain and ranges are going to be written in inequality form. So we'll take a look at a few more cases in the next problems as you practice. So take a minute to kind of work through these, pause, and before we check our answers. Pause here if you think you got it, and practice on. Otherwise, what we're going to do is just kind of work through a few more explanations of how this works. So if we're looking at our domain, again, we are looking at our x values. So going left and right, this is going to go both ways to infinity. So this is going to leave us with our x is equal to all real numbers. Everything's covered. And if we look at our range, which would be up and down, well, even though these arrows are kind of slanted down, that means they're going all the way down, all the way up. So this would be a case of all real numbers for your range as well. Okay, if you look at 4, if you're looking at your x values, now these are going down and to the left, so when you are looking at your left and right, we can assume that both of them are going to go both directions forever. So if you're looking here, all of these numbers just kind of get covered. This is another situation where x can be all real numbers. But when we look at our range, it looks like we are looking up and down. Well, that's going down forever, but when we go up, this one does have a point where it stops. So looking up here on your y-axis, 1, 2, 3, 4, 5, looks like that maxes out at a 5. This is going to tell you that y has to be less than or equal to 5. Because it starts at 5, and anything less than those values are good to go. Okay, look at domain for this value. Look at x going left and right. So there's an inequality. That looks like that's starting at negative 1, goes out here to 1, 2, 3, 4, 5. So our domain starts at negative 1. So x is greater than or equal to negative 1, but less than or equal to 5. And if we look at our range, again, it looks like it's what's the highest value, what's our lowest value on that y-axis. So that looks like it's going to be a positive 3 to a negative 3. So negative 3 is our bottom, so y is greater than or equal to negative 3, but at the same time less than or equal to positive 3. And our last one here, looking at left and right, this is going down, and this also implies left. This is going up and also kind of implies that it's going to the right. So this is an example of all real numbers. X is going everywhere left and right. We can find a value. And it looks like the same thing's going to happen with y, because both of these are kind of pointed up and down. That means our range covers every value. So we could say y is equal to all real numbers. Okay. Hopefully those examples went pretty smoothly for you. At this point, take a few minutes to practice numbers 7 through 14. Pause now before you check your work. Take a second here. Now you will see that for some of these, the answer keys, you could rewrite these as x equals all real numbers, y equals all real numbers, and etc. And if we're looking at a few of these ones that are going up and down, right? Well, think about your x values. Having that vertical line there basically limits your x values to only equaling 2 because it goes up and down. Same thing over here with this horizontal line. Looks like we have y equals negative 4. Well, there are no other y values anywhere in this graph. So the only one we can have is the range of y equals negative 4. The rest of those all look pretty self-explanatory. And on these 11 through 12, a few things to kind of note. Pay attention here to the fact that this is an open dot. So when we have open dots, we cannot have equal to that 5. It's just less than. And the same thing with the range. When you're looking up and down, it's greater than 2, but not equal to -2. The rest of these kind of work, through, but just kind of make sure when we're looking at our lowest value, -4, to our farthest x value, 5. And the same thing, it can do anything in between, but remember, for range, we're starting down here at -3 and up to 5. The rest of these kind of looking through, again, just pay attention to the fact that that is a open dot there. So we will see no equal signs with those, domain and range. Okay, hope things went well, and take a look and have a great day.